Hello class, this is my presentation, my proposal presentation. Uh, my group is composed of two people, Solvents Florinor and Recursion Raymond. And this is our project title, Object Counter. This is the date, what version we're on, and the copyright logo. Go to project summary. Our project is an object counter and we'll be implementing it on an Arduino. It'll be able to detect objects that's exiting and entering a specific room or area. So this project can be used as a tracking system when, let's say, we're trying to monitor how many people go in and out of a place or any room, for example. I decided to do this project because I wanted something similar to use in my home, and I came up with it, and I was thought it would be a good idea. I already started implementing it. So this is what the project will do, and this is the technology stack we're using. We'll be coding it with C++, Arduino C++, and we'll be using we are using two sensors, specifically the FC51, and the two sensors um, will be placed in opposite direction of each other because one will keep track of the object that are exiting and one will keep track of the objects that are entering the room. And these sensors can recognize heat, so that's how they pick up the object and know that a person or anything is passing by, entering or leaving the room. And the 7-segment display will be used to output the number that's of object that's actually inside of the room at the current moment. For example, if we put the system in place and 4 people gets in and 3 people goes out, then only one person is technically inside the room as far as the system is concerned, because that's how many people it registered in and out. So one would show up on the 7-segment display. This is a quick little schematic. I'm sorry for the for it's not that neat. That's what I can come up with right here. This is the Arduino, and these are wires connected to registers that will activate the 7-segment. It's 7 lights, so each of these registers of these wires will be connected up appropriately to the lights to activate the LEDs. For example, if I want to show one, then the I think B and C will go on and so forth and so on to properly put the numbers, output the numbers. And as far as the sensor, this is the schematic right there for the sensor. And yeah, it'll be connected. The outputs will be connected, and VCC IR sensor is gonna be connected to the board, the actual, not the Arduino, but the board that we'll be using. The VCC will be connected to that, and ground will be connected to the ground on the board, and we have ground here on the Arduino, which will be connected to the ground of the sensor. And that's just a quick little schematic. Here, look at it again to figure out what's going on. This is the requirements for a project. Obviously, the user has to place the device somewhere where it can properly detect oh, the signals. For example, the best place to put the device would be maybe at a door inside of a room where, if people have to go in and out. So if someone has to is entering or leaving the room, they have to go through the door. That obviously would be a good place to put the device. And obviously the system has to be able to detect the people, or I guess we can say the objects that are going in and out, because when we talking about the signals that the sensors are going to recognize, it's not just people. For example, if it's determining heat. So let's say, for example, someone's hand goes in front of the sensor, then it'll read it in as an object, or anything really that has heat in it. And for if whenever someone goes in, the counter is gonna increment. Whenever someone goes out, it's gonna decrement because someone just leaves the room, enters the room, it goes up by one. And the output of the number of people that's currently in the room will be shown on the display. And that's very important point that I want to make. The system should never decrement past zero. We don't want any negative numbers, obviously. So whenever, let's say, there is nobody inside of the room and someone goes out, and the system was not set in place before that person was already in the room, then it will not actually goes to a negative number. It will just stay at zero. Since we're using one 7 segment display, we're not using two, so we can't count into effect 10 or up. As soon as the system hits 9, it's gonna stay at 9. For example, if someone goes, if there's already 9 people inside of the room, and that the system has read, and someone else goes in, then it will just stay at 9 because we won't be able to show 10 on the display. And this is the use case diagram. It's kind of the same as the requirement, place of the device, the tech object, and increment and decrement, display, increment, do not increment past 9, do not decrement past 0. Just take a look at it right there. And the sequence diagram, same. We have the user, the system, and the 7 segment right there. As you can see, just gonna go to this example. On the 7 segment, the system, whenever we try to increment past 9, it's actually gonna go back to the system and do nothing. For example, if it's 0, it's gonna go back to the system and do nothing, and it's not gonna increment. But if it's between 0 and 9, and it's gonna increment properly and goes and output it to the 7 segment, and right there. And and of course, as soon as the system is placed, the output should be set automatically to 0 because the system just started. The system was just set in place. Therefore, it should not pick up anyone thus far. Let's go to the implementation. We already all parts. We downloaded all this software and to program the Arduino. All that's already done. As of right now, we're currently working on the code, and we're setting up the hardware. I think that we just finished that yesterday. So the hardware is done setting. We've done setting up the hardware, and we're currently working on the code. We're finishing up the code as we speak. And for the hardware, pretty much what we did was we just followed the schematic right here. That's pretty much it. And we just made sure that the sensors were set up opposite of each other, because one of them will be reading in and one of them will be reading out, for sure. And this is the timeline. We ordered all components, download all programs, look up tutorials done. We're working on the object counter code, which is the C++ code that I mentioned. We just finished the breadboard setup, so I guess since I created this timeline a week ago, I thought we weren't going to be done with it yet, but I guess we are. So we can change this to done. And we still have to upload the code on the Arduino, because we have to finish the code, upload it on the Arduino, debug it, test it, and then present the final presentation at the end of the semester. So that's about it. I think I went over everything that is important to our project. If anyone has a question, just email me or listen, and we'll be happy to help you guys. This is our names right here. Thank you.